My name is Jan Vasbinder. I'm the director of the Complexity Program. And ladies and gentlemen, I welcome you to the workshop Complexity and Governance. It is not necessarily the first of its kind, I'm not quite sure of that, but I think it's going to be quite a unique workshop. And that is to a large extent to the task that we give you. This is a workshop, so you have to work. And the task that you have ahead of you is that we will want you to help us identify research questions that must be answered in order to be able to formulate relevant and effective policies that address the complex problem that governance has to deal with. Now, in other words, to put it a little more simple, we ask you to help set up a research program on complexity and governance. Now, unfortunately, both governance and complexity are not very clearly defined, so you have to do your work in a rather fuzzy background, against a somewhat fuzzy background. But I will, in the coming 15 to 20 minutes, try to give you some historical perspective about Singapore and complexity. Actually, Peter Ho did it all already, but I'll put it in a little different terms. And keep in mind what Peter said, because that is actually a much richer background than I can give you. This will, by the way, not clear up the fuzziness that you will have to deal with, but it will give you some context for the task that lays ahead. And that is a context, I must admit, that is seen from an expat's perspective, so that it's biased and distorted. That is quite inevitable, but it may touch on some of the essentials that we will have to deal with. Now, following that, I will talk a little bit about complexity science, because not all of you probably are fully aware of what it is all about. I'm not fully aware of that either, so that puts us on equal footing. And then I will try to give you some indication as to where complexity science differs from the traditional science that you're familiar with. And then I'll make a few remarks on complexity, on governance, and the combination of complexity and governance. But let me start with Singapore and complexity. Once upon a time, and Peter referred to it in his first slide, but upon a time, Singapore was a very simple place. It had one party, it had one layer of government, it had one boss that made the decisions, it has an extraordinary good civil service that prepares and executes those decisions, and it had one measure for results, the GDP per head of the population. Now, given all that simplicity, why would Singapore embrace, or why should Singapore embrace complexity? And I think the answer to that is hidden in the different definitions that you can give of complexity. And the first one is complexity is the lack of simplicity. It sounds a little bit childish way of putting it, but complexity is the lack of simplicity. And simplicity meaning that you can study things in isolation without the interactions with the other things around them. So the essence of complexity in that from that perspective lies in the interaction. That was put in a very nice way in a review of a book by John Holland that appeared in Science about 6 months ago. And the book is Signals and Boundaries, and I would recommend everybody that's interested in complexity to read it. The review said, complex systems do not easily lend themselves to analysis. That is, the process of taking apart a system and examining its components individually. If taken apart, many complex systems lose precisely the character that makes them complex. The essence of these systems, then, seems to lie not in the nature of their components, but in how components interact. The government of Singapore was woken up to this essence on 7 May 2011. On that day, the population of Singapore gave a strong signal to its government that a city-state is a complex system, and its government must recognize interactions as a key to governance. Interactions, in this case, means interactions between agencies and government. In Singapore, that's called the whole of government, and interactions between government and its citizen. Yesterday, we heard a new term for that. It's the whole of nation. Now, second, the outcome of that election was one compelling reason why Singapore needs and should embrace complexity. The second reason follows from a definition of complexity that I borrowed from Brian Arthur. Many of you know him, but Brian is one of the leading complexity scientists of our time. He fathered complexity economics. He's also the chairman of the Science Advisory Board to the NTU Complexity Program that will shortly be the NTU Institute for Complexity. Brian defined complexity as complexity is about the propagation of change. And so the second reason for Singapore to embrace complexity directly follows from that. Singapore needs to secure its economic and social future in a world that changes ever more rapidly and ever more unpredictably. Peter has alluded to that quite eloquently. Now, Singapore is small and has no resources of its own. Its growth and well-being hinges on the capability to find, develop, and exploit strategic positions. It did so in its development of its harbor, in creating a safe and lucrative landing place for large multinational corporations, and in attracting and in development the financial industry, the financial sector. Now, to find new strategic positions requires insight in the changes that take place in the world and in the ways these changes are propagated. Complexity science may lead to such insights. The classical reductionist sciences definitely will not. And there's a third reason why Singapore should embrace a complexity science. The thinkers in its civil service have come to realize that the problems that the world and Singapore faces are complex by nature and cannot be solved by hierarchical or linear models of governance. Singapore is one player in that world. Recognizing the essence of interactions in analyzing and addressing those problems may be a key to finding the strategic positions that may be exploited. So I think there's three reasons why Singapore should embrace complexity. First of all, it's a complex system itself. Second is its future money-making strategic positions will be determined by a superior insight in the dynamics of the changes in the world. And the third one is that the classical linear approach to solving the big problems of the world do not work anymore. There may be a fourth reason, and that has to do with the philosophy of Taoism and its practice in martial arts. Taoism is the millennium-old Chinese expression of complexity. Because of its heritage, Singapore might be naturally inclined to embrace complexity from that point of view. If so, there may be enormous value in establishing a rapport, a conversation between Taoism and complexity science. And such a rapport may lead to a source of Eastern creativity and to ways that we can tap that creativity to address the big problems of our world. Now, Peter once actually said today also that, in other words, that the thinking about the future has been well established in Singapore since 1980 already. He also said thinking about the world is very highly connected to complexity. Yet, complexity science has arrived late in town. Now, what is complexity science? And how does it relate to the science we know? And what is it focused on? Already in 1948, Warren Weaver, at that time in the American Scientist, wrote an article, an iconic article called Science and Complexity. In that article, he answered the first part of the question, how complexity relates to the science we know. He described the progress of science by marking three types of problems that were central to the scientific behavior that started in the 17th century. The first type of problems was was the focus on what I would call the science of Newton. That science dealt with 2 to 3 or 4 variables that could ultimately be reduced to one formula. And there's many examples. Ohm's law, I mean, the relation between force, mass, and acceleration, and actually the E is mc squared. They're all typical examples of problems of Newton's physics. Warren called those problems of simplicity. The second type of problems that he characterized is the subject of the science of statistical physics that started around 1900. Statistical physics deals with very large numbers of particles or variables, such as molecules in a gas, in a space, and all these act independently, unpredictably, and very erratic. However, the system as a whole has average properties that can be analyzed and predicted. And using probability theory and statistics made it possible to conquer those type of problems. Weaver called those problems of disorganized complexity. Now, solutions to the first two types of problems have generated game changers in our world, like vaccinations, antibiotics, cars, television, pesticides, nuclear energy, plastics, computers, mobile communication, internet, and many more, and there's more to come. But the underlying science that led to those game changers gave us no insight whatsoever in the impact of those technologies on our lives, or in underlying principles that govern interactions within and between natural, social, cultural, or human-engineered systems. To do that requires a third type of problems. It requires a science that focuses on a third type of problems that Warren Weaver categorized. And those are problems in which the number of variables is too large to reduce them to a single formula, and where the variables themselves show as the essential feature of organization, and thus cannot be analyzed by the classical statistic methods. Warren named these problems the problems of organized complexity. And these are the problems that complexity sciences focus on. At the time that Warren Weaver wrote his article, there was no science that could address such problems of organized complexity. And as he indicated already in 1948, such problems would only be solvable with digital computers which at that time still had to be developed, and with teams of scientists of different disciplines that worked very closely together. Now, what does complexity science focus on? In its core, complexity science focuses on the question, what is the more in the expression, the whole is more than the sum of its parts? Where comes that more from? What makes the total to be more than the sum of the parts? Of course, from the practical engineering and policymaking point of view, this question translates into how can we design and manage a complex system so that it produces the more that we want? And I might add, without the side effects that we do not want. In his article, Warren Weaver listed a large number of such complex problems, and I'll mention just a few to give you a taste. Where does the invisible hand of Adam Smith come from? What makes water wet? How can one explain the behavior pattern of an organized group of persons, such as labor union, or group of manufacturers, or a racial minority? On what does the price of wheat depend? To what extent is it safe to depend on the free interplay of such economic forces as supply and demand? And to what extent must systems of economic control be employed to prevent the wide swings from prosperity to depression? And here's a question he did not ask, but that is totally within the same type of problems. How should Singapore plan its future? Now, this is what Warren Weaver said about the progress in science that is required to solve those problems. He said, those problems, or these problems, and the future of the world depends on many of them, require science to make a third-grade advance. an advance that must be even greater than the 19th century conquest of problems of simplicity, or the 20th century victory over problems of disorganized complexity. Science must, over the next 50 years, learn to deal with these problems of organized complexity. Now, almost 70 years after the problems listed by Warren Weaver, all those problems, or those questions, still point to fundamental open problems in complexity science. So has there been no progress? Yes, there has been progress. There has been enormous progress. That progress has gone hand in hand with the increasing speed and availability of computers. And as the speed of digital computing increased, new ways to model and simulate computer systems, complex systems, came into being. And as the computer networks developed, so developed the insights and interest in complex social networks. Complexity science acquired a vocabulary that, even though not yet internally consistent, has started to define the science. And complexity science progressed so far that it is now possible to ask questions of complexity science from the perspective of actions to be taken. In his book, Harnessing Complexity, Bob Axelrod asked this question. In a world where many players are adapting to each other and where the emerging future is extremely hard to predict, what action should you take? In his book, Axelrod examines how the dynamics of complex adaptive systems can be used to achieve one's goals, and how to design organizations and strategies that capitalize on the opportunity offered by complexity. At the same time, the problems that are now recognized to be complex have greatly outgrown the tools and methods that complexity science has been able to offer so far to analyze and handle those problems. So there's an enormous need for more of that science. And in that respect, governance provides a great opportunity. And that is because it provides a set of complex problems that individuals, society, and government are faced with every day. And because solving and managing these problems requires a deep insight in the underlying mechanisms that lead to their complexity. Thus, governance provides a strong and practical focus for an enormous scientific challenge. Or you might say governance provides an enormous practical challenge to complexity science. How can the insights coming out of complexity science be translated in policies to address the complex systems we live in? Or simply, how can complexity science be used in policymaking? Now, this workshop is meant to shed light on that question, and more in particular on the question what research can do in combination with practice to bridge the gap between science and policymaking. Now, I should clarify the term policymaking. In essence, policymaking is about defining goals to be achieved and in finding ways to achieve those goals. So policymaking consists of two major thrusts. The first is to determine which goals are to be pursued, and the second is to find and implement the best ways to pursue those goals. It looks quite simple, but it is not. It is only simple in a world where one step predictably leads to another. And we do not live in a world like that. In fact, we never lived in a world like that. And a lot of the problems that Singapore and the world faces result from the fact that most of us in the past and still now believe and have believed that we did live in such a simple world. In a simple world, you think that a strategic plan shows you the path from where you are to where you want to be. In a complex world, you know that a strategic plan shows you a direction in which you might want to start your journey. We live in a complex world. It is a world we do not understand and in which we cannot predict the future. We can try to plan it, but what we know for certain is that the future reality will be different from the ones that we planned for. That is because the natural and dynamic interactions between all atoms in the cosmos, or to stay closer to the purpose of this workshop, between individual people, organizations, and technology, because those interactions make that we cannot predict, and that the future will be different than we think it will be. In other words, it is because our world is complex, as our natural, cultural, social, and human engineered systems are. Better understanding of the underlying mechanisms that lead to that complexity will lead to the ways to harness it. In terms of this workshop, the design and management of governance systems will strongly benefit from a thorough understanding of the system they intend to govern. Now, what are those ways to harness complexity? And what are the roadblocks on that way? And do we know those roadblocks? Or do we need to remove them? What we ask from you in this workshop is to help us identify key questions with which we can, key research questions with which we can find those roadblocks and remove them. And I'm talking about the roadblocks that hamper the translation of theory into practice. Peter Hall likes to call this bridging the gap between theory and practice. So instead of roadblocks, we might also call them building blocks with which we can build the bridge. To build such a bridge is a serious business, and we that is the NTU Complexity Program, intends to set up a research program to deal with that business. To help us ask the right questions for such a program, we have invited you as speakers, and you in the workshop. The speakers come from the world, both from the world of theory and the world of practice. You as participants mostly come from Singapore, which forms the context within which theory must be put into practice. Now, with that, I would like to introduce Jan Staman, who will be our moderator today and tomorrow, and who will set the stage as to how the workshop will be run. I will shortly introduce Jan. I've known Jan, I don't know how long, 15 years or so. Jan used to be a veterinarian. I don't know him as a veterinarian. I know him as a strategic policymaker in the Ministry of Agriculture in Holland. He's also a lawyer, or he studied law, I should put it that way. I asked him yesterday, how will you introduce the speakers? And he said, well, I just asked the speakers to introduce themselves. So Jan, maybe you tell a little bit more about yourself. But Jan is from Holland, so that we have been concocting this workshop a little bit in another language than the ones we speak now. But that's Jan, the floor is yours.